Hi there, in this lesson we're going to be looking at dividing rational expressions. And just like multiplying rational expressions, we treat these things the same way we would treat any type of fraction here. So if I consider these first couple examples, if I'm dividing two fractions when I'm dealing with numbers, remember I would change this, instead of dividing two fractions, I would change it to multiplying by the reciprocal. So I'm going to change this to multiplying by a 36/7. And now it's a multiplication problem. I do the same kind of reducing that I always do. I cross-reduce the 21 and the 7 reduced to a 3 and a 1. I cross-reduce here. I can reduce this to a 1 and a 3. And now I multiply straight across. That gives me a 9/1, which is just 9. Okay? Same thing with this one. Remember, dividing by a fraction is the same as multiplying by the reciprocal. And now from here, I do any kind of reducing that I can. This reduces to a 1 and a 3. This reduces to a 3 and a 1. Even here, the 3/3 I can reduce to 1/1. And so what happens here, I've got 1 times 1, which is 1. So I get 1/1, which is 1. Okay? So when I'm dealing with fractions, just dealing with numbers, I change division to multiplying by the reciprocal. And then I treat it just like any other multiplication problem. When we're dividing rational expressions, we're going to do exactly the same thing. We're going to change division to multiplying by the reciprocal. After we've done that, we essentially have a multiplication problem, which we're going to do the same thing that we did the other day. We're going to factor everything completely. We're going to cross out any common factors, anything with a numerator, with anything in a denominator. And then we're going to multiply straight across. Okay? So really the key step here is to change division to multiplying by the reciprocal. And then from there, it's the same basic steps we've been doing. We factor, we reduce, we multiply straight across. Okay? For example, if I look at something like this guy, my first step is going to be immediately to change this to multiplying by the reciprocal. So this first fraction stays the same. I change the second fraction. Instead of dividing, I'm going to change it to multiplication. And I just flip this second fraction. I change it to multiplying by the reciprocal. And now I do the same things that I've been doing. Okay, so I factor everything completely. The first one, the numerator factors into a b plus 2 squared, which is b plus 2 times b plus 2. In the denominator, I can already see that this is going to have two steps. So if I take that off to the side for a moment, again, it's okay to take work off to the side. I factor out the 2. That leaves me with a b squared minus 4. And b squared minus 4 is a difference of squares. It's a b plus 2 and a b minus 2. So factored completely, I bring this back over here. That's a b plus 2 and a b minus 2. Over here, the 5b minus 10, I can factor a 5 out of, which leaves me with a b minus 2. And then this just stays as a 4b. And now I cross out any common factors here. I've got a set of b plus 2s I can cancel out. The b minus 2s can cancel out. And now in my numerator, it looks like I'm left with a 5 and a b plus 2. Let me rewrite that. That didn't look very good. In the denominator, I've got a 2 times a 4b, which is just 8b. And that's it. So I change division to multiplying by the reciprocal. And then I do the same basic steps. I factor, I reduce, I multiply straight across. For this one, that first fraction, again, this guy is going to stay the same. And we can think of this as being over 1. I change division to multiplying, and I flip the second fraction. So I multiply by the reciprocal. And now from here, I factor everything completely. Once again, I might take this 6x squared minus 13x plus 6 off to the side. I build my bridge. The two numbers are a -9 and a -4. This one, you might have to use your factoring by grouping. You split up that -13 into a -9x and a -4x. Everything else tags along for the ride. So we're just using all the factoring knowledge we have. I group the first two together, group the second two together. Out of the first two, I can factor out the 3x, which leaves me with a 2x minus 3. Out of the second two, I can factor out a -2, which leaves me with a 2x minus 3 as well. So right away, I can see my two factors of the 2x minus 3 and the 3x minus 2. So taking this back over here, that's a 2x minus 3 and a 3x minus 2. that whole thing is still over 1. Over here, I can factor out. So I factor out that 2. That leaves me with a 2x minus 3. In the denominator, I can also factor out a 2, which leaves me with an x minus 7. And now from here, I start canceling out what I can. In this one, I can see that the 2's cancel. And that's about it. Had I not remembered to change this to multiplying by the reciprocal, I might have accidentally canceled out a little bit more than that. But in this case, that's all that's going to cancel out. So now my numerator, it looks like I have a 2x minus 3. I have 2 of those, so I'll write that as a 2x minus 3 squared. I also have the 3x minus 2. And then in the denominator, it looks like I've got the x minus 7. All right. So in this particular example, not much canceled out, but that's just the way it goes sometimes. Okay, we factor it, see what cancels out, and then go from there. And we're going to leave this in factored form. It's far easier to do it that way. If I look at this one, this can look a little bit daunting, a little bit confusing, but really what I have is a fraction over a fraction. In other words, a fraction divided by another fraction. If you want to think of it this way instead, if that's too difficult to look at, we can look at that top fraction, which is the 4x plus 6 over the x squared plus x minus 12, and then consider that being divided by the 2x squared plus 5x plus 3. So you can write your division horizontally first if you want. And now we can change that to multiplying by the reciprocal. So I had the 4x plus 6 over the x squared plus x minus 12 times, I change this to multiplication, and I flip that second fraction. So I change it to multiplying by the reciprocal. And now I can factor everything completely. In that first numerator, I can factor out a 2, which leaves me with a 2x plus 3. In the denominator, I can factor this into an x plus 4 and an x minus 3. Over here, I can factor the x squared minus 9 factors into an x plus 3 and an x minus 3. That's my difference of squares. The denominator, I might have to take off to the side here. I build a bridge and I factor it. For this one, again, we're factoring by grouping. We split up the middle term into a 2x and a 3x. Everything else tags along for the ride. And then I do my factoring by grouping. And it's always a good idea, especially when it's something with factoring by grouping, to take it off to the side. Here I factor out the 2x. Here I factor out a 3. So now I can see my two factors are the 2x plus 3 and the x plus 1. Remove that to give myself some space. And now I start canceling some things out. The 2x plus 3's cancel out. The x minus 3's cancel out. It looks like that's about it. In the numerator, I'm left with a 2 times an x plus 3. In the denominator, I'm left with an x plus 4 and an x plus 1. And that's it. That's all there is to it. Okay. If I look at the next one, again, we have this big, giant, ugly fraction. I'm going to go right to multiplying by the reciprocal. Again, you can think of this, write this out in terms of division horizontally, but I'm just going to take this top fraction and leave it the way it was, as the 3x squared minus 7x plus 4 over the 4x. And I'm going to change this to multiplying by the reciprocal, so I take this second fraction and I flip it, so it becomes a 12x squared plus 8x over the 2x squared minus 20x plus 18. All right? And now I start factoring everything completely. Again, I might take some of this work off to the side, just because, especially when I see a coefficient out front, I know that I might have to do some factoring by grouping, and I don't want to have to do that within the confines of that fraction. So here I build a bridge. That's a 12. The two numbers are a -4 and a -3. I split up that middle term into a minus 4x and a minus 3x. And now I do my factoring by grouping. I group the first two together, group the second two together. Out of the first two terms, I can factor out an x, which leaves me with a 3x minus 4. Out of the second two terms, I can factor out a -1, which leaves me with a 3x minus 4. So now my two factors are the 3x minus 4 and the x minus 1. So coming back over here, I've got a 3x minus 4 and an x minus 1. The denominator doesn't change. That can't be factored any further. It's a 4x. Over here, the numerator, all I can do is factor out the greatest common factor, which is a 4x this time, which leaves me with a 3x plus 2. The denominator, I'm going to take this guy off to the side, so let me erase the work I did before, get that out of the way. And I'm going to take this denominator off to the side. I've got the 2x squared minus 20x plus 18. Right away, I can see that I can factor a 2 out, greatest common factor. And if I pull that down to give myself a little bit of space here, oh, apparently it's all attached. So let me just build a bridge inside here. There we go. That's a positive 9. That's going to be a negative 9 and a negative 1. Since I factored out that 2, 2 is going to tag along for the ride, but what's inside I can do my shortcut with now because it's got a leading coefficient of 1. So I've got a 2, I've got an x minus 9, and I've got an x minus 1. All right? And from here, I just start canceling out everything that I can. I notice right away that I've got a 4x that I can cancel out. And I've got an x minus 1 that I can cancel out. And it looks like that's about it. So in my numerator, I'm left with this 3x minus 4 times the 3x plus 2. In the denominator, I'm left with a 2 and an x minus 9. That's all there is to it. So again, when we're dividing rational expression, I change it to multiplying by the reciprocal. I factor, I reduce, I multiply straight across.